Yeah, we'll start. Okay, yeah, today we will talk about cryptography. So what is it, how we can apply that in current accounting system, what like the potential attacks and vulnerabilities with cryptography, why you should use that in modern like accounting system, etc., etc. So today, like really like specific theme about cryptography. It will not be like too difficult. It's like only like some intro. Okay, what the cryptography is. So cryptography is a science that ensures the confidential privacy and authenticity of information. So cryptography is something that allows your data to be protected from hackers, protected for like different reasons. Cryptography protects the privacy of your data, integrity, authenticity, and if you work with some data, you should use cryptography for achieving like security. What the modern cryptography includes? Firstly, that's symmetric encryption schemes. So these schemes use key pair for direct encryption of some information. So if you want to protect your data from like some party that can be between you and recipient of this data, you should encrypt that. And you can use a symmetric encryption schemes. You can use symmetric encryption schemes. The only like difference that in symmetric scheme, you will use only one key. Asymmetric encryption schemes require two keys, one public and one private one. You are using a public for data encryption, and only the owner of the private key can decrypt this data and receive like initial data. Then digital signature schemes. So if you want to protect some data, some document from modification, you can use digital signature. So digital signature can prove that you're author of some document, of some data. Also, you can see that if you use Bitcoin or other cryptocurrency, you are using digital signature for signing transactions. And everyone can verify that if transaction is signed by account, by person in party, it can be validated, and everyone verifies the signature itself. Then hash functions. So you can use that for receiving like a digital image of some data, but really short. You can take some I don't know, picture, put that in hash function and receive like only unique identifier of this data. Then key management schemes, for example, let me provide example. It's a Diffie-Hellman schemes, for examples. So this scheme allows you to form a shared secret between several parties and use this for encryption, for example. Then cryptanalysis method. That's a science that provides you techniques for breaking some existing encryption algorithms. So we can divide cryptography or cryptology to cryptography that allows you to secure some data, and cryptanalysis. So that's a science that allows you to have some like data broken. And the last one, post-quantum cryptography. So that's set of algorithms that will work after all hackers, all attackers take quantum computers. So no worries, after like each person in this world has his own quantum computer, no worries, your data will be protected thanks to post-quantum cryptography. Okay, let's start what exactly, how exactly your data should be protected and what should be achieved by cryptography. The first one, that's the data confidentiality or data privacy. It says that this property achieved if nobody can receive your data. And for achieving confidential privacy of the data, you should use encryption. The next one is data integrity. This property includes the ability to confirm of integrity some data, and this property doesn't allow to anyone modify your data. So if the person doesn't have rights for modifying data, he can't do that. Then data authenticity. That's a property that says that allows you to verify the owner of some data. If I left a digital signature, everybody can say that, okay, this signature is correct, this data wasn't modified, and you're current owner of this data. And the last one is data accessibility. That's a property that says that the owner of some data will receive access and will have access anytime. Okay, the question to our group, what exactly from this list you can't reach using cryptography? So there is one property with privacy, integrity, authenticity, and accessibility that can be reached with cryptography, with math. What is your opinion about that? Where is the chat? Authenticity, no, it's not true. Integrity, also, it can be. Accessibility, yeah. Olena, let's give Ruslan 1 point on our course because that's right. Okay, let's return to the slide. So for confidential, for privacy, you can use encryption, and encryption, that's a mess. For integrity, you can use hash functions and digital signatures. So that's math. This is cryptography. The next one, authenticity, you can use digital signature for like providing like proof that you are owner of this data, you're author of this data, and this is a cryptography. And you can't use a math method for receiving accessibility. So this property can be achieved only through like decentralization. So if your data is stored on a lot of computers, a lot of servers, it means that you can access to anyone and receive your data back. But like this property, you can't reach with math. Okay, let's start with definition of cryptographic keys. A cryptographic key is some digital sequence, so some string with bits of a certain length, created according to certain rules. And the cryptographic keys are used for cryptographic algorithms. So cryptographic key is a cornerstone of the security, because your algorithm can be secure as possible. But if you lost your key, if you forgot your key, if somebody just has stolen your key, it means that the cryptography will not allow you to achieve like these properties we mentioned before. But if you protected your key or your keys from everyone, you can trust to math, you can trust to cryptography. Also, yeah, there is like only one key, and you can use that, for example, for symmetric encryption. But there is like a definition of key pair. What is it? It's a definitely it's two keys. The first one, it's a private. It's a large random natural number. So you can generate that, and you should store that securely. And the second one, that's a public key. It's something that should be derived from the private key and can be open, can be revealed to everyone. So you can post that in your Facebook profile. You can leave that on some on any place, on any public place. Everyone can receive your public key, and everyone can use that for something. For some exactly, we will discuss later. And it's pretty interesting that relation between private and public key should be defined by one-way function. So how is it? For example, you need to create your account in Ethereum. Firstly, you should generate a random number, random or pseudo-random number. Later we will discuss what's the difference. And you should generate a random number and receive a private key from this random number. You can use it directly, or you can put that in hash function and receive a private key. And you shouldn't reveal this private key to everyone, because revealing of this key can provide to attackers ability to just steal your money or like receive some information. Then you can use private key and some derivation function for receiving a public key. So firstly, you should create a private, and then you should derive a public one. And it's pretty interesting that the scheme that allows you to either receive a private key from the public key should be absent. Because if their link will exist, everyone can receive your private key and use that for yourself. So this should be a one-way function. What the one-way function is? This is a function that firstly calculating output value is fairly simple for any input argument. And second one, it's very difficult to compute an input argument for a given output value. So when you derive a public key from the private one, there isn't like an easy math method to receive a private key back. So you should store that, you can derive public, reveal that, post that, and nobody can receive your private key if they have only like public value. So yeah, if there is some like attack, it means that any attacker, any hacker can receive your private key and use that for signing transactions, for receiving data, for opening some data, etc., etc. Okay, what should you know for secure deriving of your private keys? That's important for the owner of the key, that no one else can still calculate or generate the same key data. So you should trust to the generator that will derive you like a private key. Because if somebody can steal that from your wallet, from your storage, or somebody can calculate that, because, for example, if you derive your private key using a date of the birth, or somebody can generate the same key data because, for example, it didn't use like some unique entropy for deriving that. It means that if attacker can still calculate or generate, he can receive your private key and he can use it later. And for example, Bitcoin users can use their own random number generators that usually is built in computers and mobile devices and some hardware wallets, etc., etc. So it means that you can use any generator you want, but you should be sure that this generator is protected, built in your wallet, built in your like application. So you should trust to this generator and you should trust to this wallet. Okay, let's go on. Yeah, there is a definition of hash function. As I said before, a hash function is something, it's like math operation that allows you to receive unique identifier of some data. So that's a function is converted an array of any like input data. It can be some string, it can be some file, it can be some document, it can be movie, it can be picture, music, any data can be put in a hash function, and you will receive only like fixed length string. And in hash function, you will use like only like primitive operations. Usually it's like logical operations, so XOR or AND. You can use also adding of some elements in internal data, but it's pretty important to know that hash function works like the same way for like the same message. For example, if now you will hash hello world and you will hash that in 1 month, the hash value of these messages will be the same. And it's also important that hash function is one-way function. It means that if you have only hash of some data, you never will receive like the input message, because yeah, that's impossible. There isn't a way to revert all these operations and receive like initial message. Yeah, also, yeah, let's provide an example of how simplified hash functions works. For example, you just can take some number and just calculate and just receive the product of like the digits in this number. So you can sum everything and receive like only a value of 9. If you will repeat that in 1 week, in 2 weeks, in months, so everything will be like, you will receive the same process and you will receive the same hash value. But this, why this hash function is silly? Because hash function should provide you a unique value for some unique internal data, for some unique input data. It means that if you will replace digits in this number, as in this example, so the value of the hash function will be the same. It means that everyone can change this data and just receive the same value. So this is not a secure hash function. Let me provide you a secure hash function. You can just Google that. Yeah, there is like, yeah, there are a lot of different libraries, and you can see that we can receive a unique output data for some unique input data. If you will replace only like one letter, you can see that the output hash value is different, totally different. Also, if you change only like one bit, you can see that hash value starts with BC, B1, etc. You can change 1 to 0, and you can see that the output hash value is totally different. You can see that there are a lot of different hash functions. You can see CRC family, MD family, SHA family, Kichak family, etc. So you can use any, but in some protocols, in some algorithms, only like the allowed list is presumed. Okay. Let's move on. Yeah, what are the requirements to the hash function? The first one is collision resistance. It means that, for example, in these hash functions, it isn't protected from the collision, because a collision is when you put a different set of data on the input of the hash function and you will receive like the same output value. So this hash function isn't like collision resistant. But that's a requirement because, yeah, as I mentioned before, that you should uniquely identify some data by this hash value. It means that in the future, for example, you can commit this data, you can commit this hash value, and it means that later some hacker or some attacker can't replace this data because it's pretty difficult to find the separate set of data with the same hash value. Second one is resistant to the search for the first pre-image. It means that if you have some data, some document, for example, and if you have the hash value of this document, it means that it's pretty difficult task to everyone to find another set of data that will provide the same hash value. And there is a little difference between resistance to the search for the second pre-image. It means that attacker can use any sets of data, any like random sets, but he definitely will not receive the same results for this data, the same like hash value. Okay, let's go on. So you can see that correct document, if you use insecure hash function, you will receive some data. And if somebody replace your document with with some fake document, and if you use the same insecure hash function, you can receive like the same hash value. So it allows to everyone just replace the data, and later you just can't prove that you provided the correct document initially. For the secure function, you can see that the output value should be totally different. If just imagine that you created a transaction where you pay to like 10 bitcoins to Alice, and you signed this transaction, you calculated its hash value, but when you send this transaction to the network, somebody can just add 1 0 to the like amount, and it means that if hash function will be not secure, you will pay 100 bitcoins instead of 10, and that's a problem. And secure hash function doesn't allow attacker to do that. Okay, then yeah, let's see how symmetric encryption scheme works usually for encrypting and decrypting the data. In this case, you will use the same key. So it call it encryption key. If you want to receive some encrypted text, you should put on the input of this function plain text, so initial text in open form, and encryption key. You and your counterparty should know this encryption key because you will use that for encryption, and he or she will use that for decryption of this data. So yeah, there is some algorithm. You put plain text and encryption key, and you will receive encrypted container or encrypted text. Then you can transfer this container to the receiver of this data, to Alice, for example. And Alice then, if she knows the encryption key, she can use that, and she can use encrypted container and some decryption function for receiving like the plain text, for receiving like the initial message. It means that definitely previously you should agree this encryption key, because you both should know that. If Alice doesn't know encryption key, so she will not be able to decrypt the message. Okay, there is some difference with a symmetric encryption scheme. For doing that, you and Alice both you should have two keys. You will have your own secret key and your own public key, and Alice will have her own private key and her own public key. And if you want to encrypt some data and send that securely to Alice, you should use her public key and plain text. So you should use public key of the recipient of this data and encryption function. And later, like the same situation, you will receive just some encrypted text or encrypted container. If Alice wants to receive this data, initial message, she should use her own private key and encrypted text. And a symmetric encryption scheme allows to do that. It means that everyone can encrypt some data using Alice's public key, but only Alice, as the owner of the corresponding private key, can receive the data itself. You should know that you're using this approach every day, because HTTPS protocol, that's about that. You have some public key certificate, some server has a public key certificate, and you're using his own public key for, okay, that's a little bit different, because you will use his own public key for deriving like a shared secret for that. But you can simplify this process, and you can use only like his public key for direct encryption of some data. But it's like not so efficient, but that's possible. Okay, what's like advantage of this protocol? That's obviously you shouldn't agree as some common secret, because for doing like the previous scheme, you should meet with Alice somewhere and just exchange like this key between each other. In this key, in this scheme, Alice can post this data, her public key, everywhere. You can take that and right now encrypt the data directly to the Alice, to Alice. Okay, then let's go through definition of the digital signature. It's like the same signature you're using every day, so handwritten signature, but for producing that, you should use a digital keys. You know that now a lot of countries support using digital signature, like instead handwritten signatures, and that's okay. And digital signature is more secure because it's really difficult to like replace the correct signature with like the fake one, because you in ideal world you should generate a key pair yourself. Later, somebody should approve you publicly. It's like some certification authority. And later, you can sign all documents using your private key. And this like certificate authority just proves that you're actual, you're owner of this digital signature, of this public key. So yeah, when you're using a digital signature, you're protecting your documents, your data, from modification. Moreover, the recipient of this data that was signed with your signature can be sure that you're exactly author of this data. As I said, for example, when you said when you should send a transaction to Bitcoin, Ethereum, or any like accounting system, you should sign that with appropriate private key, and every validator and any user of the system can verify your signature and be sure that, for example, some balance is linked with this account. Okay, yeah, without your private keys, I can't produce your digital signatures. So that's very, very important to keep your keys like we are protected way. Okay, so how digital signature scheme works? For producing the signature, you should use like an initial message or some set of data, and you should use your own private key. Then there is some function of signing data, and as a result, you will receive a digital signature. What is it? It's some set of data, some string. Then you can transfer the message, and you can transfer the digital signature to verifier. And verifier, how exactly he can be sure that this digital signature is yours. For doing that, the verifier should know your public key, and then he will receive a message, and he will receive a digital signature provided by you. And then there is verification function, and it returns two values, true or false. So it returns a verification result. If message was incorrect, if digital signature was incorrect, or public key was different, this signature verification function will return false. But if the message is original, if public key is definitely owned by sender of this message, and the digital signature wasn't broken, wasn't modified, so this function will return true, and the verifier will be sure that you are owner of this data and you signed that. Okay, I think that's it. We have a lot of time for questions. Okay.
Thank you very much. Your question, please.
Let me see the questions in our chat. What about key generation RSA? The same situation. You should firstly derive a private key, and then there is operation of receiving a public key from the private one. It's like operation of you should use power of group generator for receiving like the public key. And later, when you want to encrypt some data, you should use power of this like message and public key of the counterparty, and later this counterparty with his own private key can receive the original message. But it's not so efficient to use RSA for encryption because it really hardly operate with big set of data. So if you want to encrypt a big set of data, you should use definitely a symmetric encryption. Okay, yeah, Igor, what's the questions?
Sorry, but I don't really understand the difference among points on collision of hash function and other 2 points, because as for me they looks pretty similar, and I don't quite get the difference between 3 points.
Okay, yeah, it's actually the points only like to last, because the first one is collision protection. It means that it is pretty difficult to have some 2 or more different texts or different set of the data that will provide you the same hash value. What's the resistance of the first pre-image? If you exactly you know your message and you know your hash value, but this message is fixed, and attacker can't receive the different message, the different any message that will produce the same hash value. In the second point, attacker can select any 2 messages, any 3 messages, 4 messages, doesn't matter, which will provide you the same hash value. So in the first case, you fixed the message. In the second case, attacker can use any both messages for receiving the same hash value. And there are 2 requirements for the hash function. Firstly, if you fix the message, attacker shouldn't be able to produce to receive the second message, the different message that will provide the same hash value. And the second requirement that without your participation, attacker can use any 2 messages for receiving the same hash value. So yeah, difference not so big, but it exists.
Yeah, now it's clear. There is last 2 points related to collision, but just in other cases, yeah. It's all about collision.
Yeah, sure. You should just remember that hash function should be collision resistant. That's it. It's a pretty simple, but it includes a lot of different requirements and definitions.
Got it, thanks.
Okay, yeah, thank you for the question. What about news hacking RSA by Chinese scientists? Yeah, that's really good message. I will try to find this new and send to our common chat. But yeah, there is news that Chinese scientists found the way of efficient broken of RSA scheme. So yeah, that's a bad news. But yeah, as I said, now scientists are working on post-quantum cryptography algorithms, so this will not be a problem in the future for changing the current infrastructures and just transferring to the new security model. But RSA, yeah, will be hacked the first.
And the question in my private message from students, are there any decentralized implementation of chain of trust for digital signatures?
Is there any decentralized implementation of chain of trust for? Okay, yeah, I got it. So, do you mean kind of public infrastructure? There are a lot of concepts. Moreover, I can send you an article we wrote 3 or 4 years ago. This describes how this system can be organized. But honestly, I didn't meet any live project that allows you to that builds a public infrastructure based on the blockchain. But it should be definitely done by governance, by someone else. But for now, like any live projects, but a lot of different concepts.
Thank you.
Yeah, Igor, feel free to ask questions.
Thank you. Additionally to new about hacking, Chinese scientists hacked RSA. Does it mean in near future we should change algorithm which every developer use now to communicate with GitHub and other repositories? Because as far as I remember, we generate RSA using RSA.
Yeah, that's true. Yeah, you know, for digital signature, mostly people use now algorithms that use elliptic cryptography, but for using RSA, and it will be changed definitely because yeah, that's a security. You can't control your money using like the weak algorithms. You can't sign different documents with lawyer using like weak algorithms. So yeah, infrastructure will be transformed, and that's not a problem. Just users will use like a different algorithms. So for them, it doesn't matter. So it will not change some UX, UI components. It will not change approach for like living a digital signature itself. It just will change some hardware, some software that supports these algorithms, but that's it. It will not change lives.
Thank you.
What's next generation after RSA we can use right now? You could hear about in digital signatures, everybody can use CDSA, for example, EDDSA, etc., etc. So a lot of countries supports like pretty same standards. For encryption, you can use now symmetric encryption, and definitely you're usually use that. So as I said, when you communicate with some server, firstly you should generate a shared secret using like Diffie-Hellman protocol, and later you just using symmetric encryption for transferring the data. Okay, that's it. Maybe I answer it. And later I think nothing will be changed because you can use Diffie-Hellman for elliptic curve algorithms and just derive this shared secret this way. Something like that.
Okay, thank you very much, Alexander.
Like one minute, I will try to find this news right now and send here, because yeah, I found it. Yeah, that's a pretty interesting article. You can read that. It doesn't matter if you will not like understand everything, but the main concepts will be clear. And yeah, Olena, I think we will like repeat this link in our chat. Resend here.
Okay, thank you. So all questions in the chat have already been answered. Maybe we can stop, and please wait for a new test and new task for you.
Also, we can like provide, I don't know, maybe 5 minutes if you have some questions from the previous lectures, from the test, you can ask right now, and we will spend, I don't know, 5 minutes for answering.
Hi, Alexander. I have a question. Sorry. I wrote in our chat room about blocks of blockchain regarding what does chain of block include, and we have a possibility to choose metadata of all transactions, but this option is not true. And my question is why? Because before, in previous answer, you mentioned that some metadata included in block header, and I thought that it's like very connected. But why is this not true?
Okay, yeah, that's a good question. That's a good question. We will, I think, in the future we will like change this question and like variance of answers because it's not so clear. So thanks for reporting. But for example, in Bitcoin, in Ethereum, in other like protocols, there are not like a field like memo data of transaction, because transaction includes only necessary data. So amount, some proof of ownership, proof of some conditions, how these coins can be spent in the future, some identifier of this transaction. But by the metadata, a lot of people understand some where you can, for example, add why you're doing this payment, so the etc., etc. So some like arbitrary data that can be connected to the transaction, but cryptocurrencies don't allow to do that. When I read, when I have written about metadata in block header, I mean, as I listed, so that's some nonce, some difficulty parameter. It's a Merkle tree from this transaction, from all transactions from the block. It can be some timestamp, etc., etc. So it's also important data, but they are not about logic of transaction itself. But yeah, you're right that we should change this question in the future because it's not so clear, and I think a lot of students made a mistake, but I think that's our bet. We will fix it.
Okay, thank you.
Okay.
We have one question.
Can you hear me now?
One more time. What are the main pitfalls in cryptography and blockchain?
Hard to say. Usually I can't define like the main. I don't know. This is hard to answer for that. Maybe yeah. I wouldn't say that. A lot of project wants to resolve this kind of capacity, but that's not a pitfall. That's kind of thing that supported like any project. It's not about some blockchain or cryptography or something like else. Number theory, it's too, so it's like a mess. That's it. Just blockchain includes a lot of not only like number theory, like game theory, because it's consensus. Cryptography, also a lot of different like kinds of math. Okay, in the quiz for the question, what is the blockchain? Why is distributed server technology a wrong answer? Even through blockchain is a distributed ledger technology. You can, honestly, you can run your own local blockchain without sharing that with everyone. it will be like centralized blockchain is deployed on the one server. So that's possible. Just blockchain allows you to order the history in some kind of in protected way. So, for example, in the future, some central bank digital currencies, some registers will use the blockchain technology, but it can be private in some times. It can be like no provided to everyone for doing some changes, for supporting like this currency. So I answered that you can run your own blockchain local on one machine, and but it helps when you synchronize your history with someone, but that's like a method of ordering of data or synchronizing data. I would say that. Moreover, blockchain isn't linked to server, because we can say that it's a more distributed system technology, but it's not about server, not about database, not about some hardware.
Okay. Okay, so it was very interesting.
Great. What are the drawbacks of central bank digital currency? It's hard to say. I don't see like any, because it's like it's a kind of right digitized currency. That's it. Drawbacks. So you can say that it's powered by governance of someone else, but that's not a problem, because like national currencies can't be issued by everyone, because it's not a crypto. So in this case, control of currency by the governance is like a necessary step. That's not like a constant, not a process. It's like a specific. That's it. It will have a lot of advantages, because it will allow to build a transparent engine for the money, for the fiat money. So everyone can see everything from the regulated perspective. So nobody can't print a lot of money without like notifying everyone. So it will provide a lot of opportunities, but I can't list just right now some drawbacks. Some specific things, yeah, a lot of, but not drawbacks. I think you mean this question, client server technology. Yeah, so client server technology is like, I don't know, HTTPS protocol, for example, TCP protocol. Blockchain, it's not like about client server iteration. It's about like organizing some history. Yeah, usually by the blockchain, we can mean a lot of things like cryptography, distributed, like organizing of the network, etc., etc., etc. But the definition of the blockchain is different. It's like a technology of synchronizing of data or organizing of data. Okay, well, thank you for all questions.
Thank you.
Very nice, yeah.
Thank you,
Thank you.
Paul. Thank you, Alexander. And see you later. Thank you.
Yeah, see you. Bye-bye.
Bye-bye.
See you, ciao.